Welcome to this video on REST API versioning. After watching this video, you'll be able to describe REST API versioning and list common approaches to API versioning. You'll also be able to describe the process of implementing URI versioning on Spring Boot. Imagine a library system where you can request books without needing to know how or where they are stored. Similarly, REST APIs allow users to request resources from a server without requiring knowledge of the server's internal implementation. A representational state transfer application programming interface, or REST API, allows interaction with resources over HTTP using standardized operations such as get, post, put, and delete. It ensures stateless communication and uses resource representations such as JSON or XML. REST APIs serve as the backbone of web services and applications, whereas API versioning helps manage changes in your API without disrupting older versions. It ensures that clients can keep using the old version while new features are added or modified. Versioning is critical as it ensures backward compatibility, allowing existing clients to continue working seamlessly. It also permits controlled changes so developers can add new features without disrupting current users. Additionally, versioning supports flexible development by allowing parallel work on new features and bug fixes. The three common approaches to API versioning are Uniform Resource Identifier, or URI versioning, where the version number is included in the URL. Another approach is the Request Parameter versioning, where a version is specified in the request parameters. And the third one is Header versioning, which includes the version in the request headers. Let's dive into URI versioning in Spring Boot. The first step is to create a new Spring Boot project using your favorite integrated development environment, or IDE, or Spring Initializer. Ensure that you include dependencies for Spring Web. Next, create a simple REST controller. To illustrate this process, let's consider a basic REST controller that includes two versions of an endpoint and returns a greeting message. Begin by declaring the package to organize your classes into namespaces. Next, import the necessary classes from Spring to enable REST functionality. Then, use the @REST controller annotation to mark the class as a REST controller and the @GET mapping annotation to map HTTP GET requests to the endpoint. Finally, define methods such as getGreetingV1 and getGreetingV2, each returning different greeting messages for version 1 and version 2, respectively. The next step is running your application. You can do this by executing the main method in your main application class, typically named Versioning Demo Application. Once the application runs, visit the URLs for versions 1 and 2. As your API grows, you may need to support multiple versions simultaneously. To keep things organized, group related controllers into separate packages or classes for each version. This approach helps keep the code clean and easy to manage. Now, let's explore an example that implements a simple user service with two versions using URI versioning. In version 1, the API returns basic user information, while version 2 provides extended user information, including an email address. Once the application runs, you can access the following endpoints for basic and detailed user information. Semantic versioning, or SEMVer, is a way of numbering versions to show clearly what changes have been made. It uses a three-part format known as major, minor, and patch. Here, the major version increases when breaking changes could affect how things work. This implies that clients may need to adjust their code. The minor version goes up when new features are added in a backward compatible way, which implies that nothing existing will break. The patch version includes small fixes that don't affect how the system works. They are minor tweaks to improve performance. For example, a bug fix would update the version to 1.0.1. Adding a new feature would make it 1.1.0, and any breaking change would jump it to 2.0.0. In this example, version 1.0.0 represents the initial release of a basic user endpoint. A bug fix that doesn't affect the API's functionality would increase the version to 1.0.1. However, Adding a backward-compatible new feature, such as returning a user's email, would increase the version to 1.1.0. In this video, you learned that REST APIs allow data requests without requiring knowledge of a server's internal structure. API versioning ensures backward compatibility while enabling the addition of new features. Common versioning approaches include URI versioning, request parameter versioning, and header versioning. Finally, Semver has three components: the major version, which indicates breaking changes, the minor version, which denotes the addition of backward-compatible features, and the patch version, which reflects small fixes or improvements.